演讲者呢是 MEF 的高级副总裁Dan Pitt 博士，他演讲的题目是编排的生命期服务Let's welcome Dr. Dan Pitt.
Good afternoon, ladies and gentlemen. Thank you for inviting me back to Beijing. This is my third time this year, and it's probably my fifth time at this sort of an annual conference. So I'm here representing MEF, which used to stand for the Metro Ethernet Forum, but we have grown way beyond Metro Ethernet matters and carrier Ethernet. I'm here today to tell you about what we're calling LSO, Lifecycle Service Orchestration, and how we create this from very well thought out and well chosen abstractions, reference points, and APIs. The reasons abstractions are important are these. Look at what abstractions did for the forwarding plane in SDN. It abstracted the forwarding plane to a match action paradigm. Abstractions are what NFV did for the network appliance. They are now what orchestrators are doing for the infrastructure, and most importantly, how applications want to view the network. They want to see the network as a delivery mechanism. They don't care how the delivery is made. They just see it as a vehicle for doing that. Now, there are right ways to do abstractions, and there are wrong ways to do abstractions. First of all, they're really only useful if they're functional abstractions. This is what you do. They don't care how what you do is done, how it's implemented. They don't care about the technology and the networking, about the transport. And if you look at an application today, a modern application in some global enterprise, it's going to go from point A to point B somewhere else, and it's going to traverse all kinds of network technologies. It might start out as Wi-Fi or carrier Ethernet and go to optical links. There might be submarine links. There might be satellite links. It might end on 5G. The application does not want to care how it gets there. If abstractions are chosen at the right level in the architecture stack, they will promote healthy innovation above and below the reference points that define the abstractions. If you think about what the Internet Protocol did, it was a narrow waist of an hourglass shape. It enabled lots of innovation in switching and routing and transmission, and lots of innovation in applications and in the session layer and the transport layer. And it's important that abstractions not constrain the implementations, and that they not dictate that implementations must follow some pretty architectural diagram. Sometimes the architectural abstractions are only useful to help you understand the problem better and to simplify it. That doesn't mean that a product sold on the market needs to fit into a box on an architecture page. Finally, I believe that it is the abstractions of the last 6 years or 7 years that are turning networking from a trade into a science. Lifecycle Service Orchestration is really a framework of abstractions for a number of components in a network that are defined by their function and separated by reference points. I will show you what these are in a moment. They're described by APIs, and we have several ways of actually depicting an API. And the reason we do them is for two purposes. First, we want to enable the service providers, any network operator, be it a telecom company, a cloud company, an enterprise, to create services and concatenate them, attach them one to another, using their choice of components that make up their network, above and below the abstraction. Sometimes these components are going to be open, sometimes they will actually be open source, sometimes they'll be closed and very proprietary. The abstractions should allow that because technology evolves. And the network operators are evolving their businesses with the technologies available all the time. They want to improve component technologies without changing everything else. And finally, I believe these abstractions foster an ecosystem of service providers, customers, and suppliers that optimizes organically and follows the latest in technology trends and business trends. That's what we have been seeing for 6 or 7 years with SDN. We are starting to see it with NFV. We are seeing it with cloud. This is the reference architecture for LSO in MEF. It's called a document called MEF 55. You can look it up on the internet. In the US, we Google it. Here, you would Baidu it. And it shows these components here. On the left, we have a customer. In the center, we have a service provider. And on the right, we have another service provider. The customer has engaged with the service provider in the middle for some kind of a global end-to-end service, starting in the geography where the customer's first office is located. But the destination of the service is in another geography, another country, where this middle service provider does not offer service. So it partners with someone locally, and that's the service provider on the right. We have the customer application coordinator on the left. And then in each of the operators, starting from the top, we have the business applications. And this, for a telecom provider, could be the BSS. We have the service orchestration function. This was a not very widely known term. Now we have lots of interesting orchestrators, from ONAP to OSM to Open Baton to proprietary ones. Continuing down, we have infrastructure control. This you're familiar with. In the world of SDN, it's an SDN controller. But it doesn't have to be only that. And finally, we have the element control and management. These are basically the switches. We have a variety of what we call APIs, although in all honesty, an East-West API is not an application programming interface. It's generally a protocol. But we call them the same. And we have the north-south ones starting at the top and working down each level. They all have names from the world of music. Someone thought that because we're orchestrating things, we have an orchestra with multiple players, but we didn't call them violin, trumpet, and clarinet. We call them legato, sonata, and presto. I will describe what each of these does in a minute. We have formal definitions, formal ways of describing this architecture and the reference points. We define APIs. We have information models for which we work with many other organizations, standards organizations, and open source organizations. We reduce the information models to data models in code. We publish some sort of standard. We call them interface protocol profile specifications, IPSs. We formally define services. We have done that for a long time in MEF. And then we have certifications of 3 different types I'll talk about at the end. Now, in addition to these formal things, we have a number of informal activities. We run hackathons. We have a developer community that works on open source software to create SDKs and sample implementations. We issued just 2 SDKs recently for 2 of the interfaces, the Sonata East-West and the Presto North-South. And we actually issue these before we issue the standards or the IPSs. What we're doing is sort of a DevOps form of standards development that includes open source software. Our MEFnet is an experimental playground with lots of equipment, and you can try network configurations and devices and software artifacts to your heart's content. We describe example implementations in the SDKs, and then we have reference implementations. And there's a particularly prominent one that I'll talk about later. So this is that picture again. I'm going to tell you what information is conveyed across these APIs, but they are not formally described yet. We are on the way to doing that with Sonata and Presto. We haven't formally done the others, and actually what we're doing is we're collaborating with some of the open source projects that implement these components to make sure that when we get to the formal definition, it's in harmony with the APIs that they need. So, looking at the left, we have two east-west APIs, Cantata, and below it, Allegro. The upper one is for business arrangements. The bottom one is for technical arrangements. The top one is mostly at the beginning of a service. The bottom one is throughout its lifetime. Basically, the Cantata interface, and you'll see the Sonata between carriers, looks at product availability. Do you have this service available? Does it work at this address? Is there a process to order it? I would like to order it now. And this will all be automated in short order. The Allegro interface has to do with the technical details of how well it's performing. What is the service state in real time? Are there some errors? Do we want to make some changes in the technical specification? Do we want to change the information rate, for example, that we come into? Looking south now, we have basically the application, or the BSS, talking to the orchestrator saying, okay, I want to activate this service. I want to manage it. Is it available? Here is the policy that governs the quality of service that you need to provide for me. You don't have to tell me how you're doing it, just tell me that you can do it. Presto is very relevant. It's really from an orchestrator to a controller. It says, create this connectivity. Here is what I need in terms of active connectivity, topology, routing, resource invitation, and performance and fault management. The next one down really goes from the controller to the network element, say from an Open Daylight controller to an SDN switch, to an OpenFlow switch. It says here, load the tables. Make this happen, actually effect the connection parameters, and tell me how it's going and what is your state. If we continue on the east-west vein, just the other two, Sonata, as you see, goes from one operator to another. Is this service available? Can I pay for it? We need a billing arrangement. Does it work at this address? I'd like to order it now. And again, in real time during the lifetime of the service, this interface tells you what is going on and allows you to change things if you wish. All this is available in the MEF 55 document, very easy to read. Now let's see how this works in an actual network kind of picture. We have here two operators. We have customer on the left. It shows a finger. That doesn't mean there's a person. This will be mostly automated. And you can see we have the service orchestration functions looking down in the carrier. And then we've got things you might be familiar with: an SDN controller, NFV Mano, VNFs, SDN switches, and other components that run an actual network. So these abstractions actually work to control real things. And these can be proprietary. The architecture does not say whether they need to be proprietary or open source or any particular details about their implementation. So here are a couple of examples of what some major operators have done using a variety of components, mostly sourced by vendors. This was an inter-carrier orchestrated layer 3 VPN done by Tata Communications in India. Telecom Italia Sparkle in Italy, and PCCW Global in Hong Kong. And they really created an end-to-end orchestrated layer 3 VPN for a particular customer that went across a very large geographical expanse. They use these common interfaces to concatenate their services for the end-to-end customer. Another example, end-to-end network as a service. We've got 10 operators that have done this. In the United States, in France, in Hong Kong, in England, and in Italy, and in India. They all agreed to use these same interfaces, APIs, and reference points. However, they implemented what's in their own cloud doesn't matter to any other operator, and they can offer an end-to-end service. Now let's look at a case of doing this with open source components. Your business application might include an OpenStack cloud orchestrator, or it could include something like VMware. The service orchestration function. I'm showing ONAP. There are alternatives, but ONAP is a growing orchestrator of choice for many global operators. Open Daylight could be the SDN controller. Could be another open source one, could be proprietary. And down at the switches, we could have soft switches running OVS, Open vSwitch, or we could have physical network switches built on the Open Compute project. Here's an example of this from 2 weeks ago. These operators built what they call an end-to-end global virtual fabric to connect global enterprises in 3 countries, 4 countries actually, the United States, France, England, and Ireland. And they were concatenating the very first instances of ONAP. They each did it their own way. The code bases were not identical, but they agreed on the interfaces. This is a proof of concept that won the POC award at the MEF 17 conference 2 weeks ago in Orlando, Florida, 2 weeks ago today. Given that ONAP only started in February or March, it was actually April when it was merged with OpenO, this is a pretty dramatic accomplishment. But it shows what you can do if you agree on the reference points, abstractions, and APIs. 2 weeks ago, MEF launched sort of its future vision, although a lot of it is current. It's called MEF 3.0. And I'll just explain these 4 parts of it. We've long defined a number of services, but they've all been related to carrier Ethernet. Now we have a very active project on SD-WAN, defining SD-WAN services and a number of use cases. We're working on wavelengths and also wireless, IP layer 3 services for VPNs, security as a service, and application services. This morning a press release went out announcing the formation of an application group in MEF and our acquisition of another organization, the IMTC, for multimedia services. So we define services so there's a common understanding of what they are. The LSO APIs, I've described these for you in this talk. You know what they do. We have certification of skills, of products, and of services. But it's no longer you send your product to some lab somewhere and it sends it back later, or you go there and take people and do your tests. A lot of it is online, it's cloud-based, it's real-time, and it's continuous. And in this vision of MEF, we're all climbing out of our silos. We have a very large community. I am here to build our community in China. That's why I'm here 3 times this year already. We have the developer community that I mentioned, many certified professionals, the open source projects and SDOs that we collaborate with to find solutions that work for everyone. We formed an enterprise advisory council of some very big name global enterprises. And we have the MEFNet platform. This is how we have to operate in a larger context. We had some awards 2 weeks ago. One of them went to a Chinese company who was a member of MEF from Hangzhou, Daho Networks, who partnered with GDS, who's also a finalist in a different category. This was in the Technology Solutions Award. recognizing leadership in service orchestration, service assurance, service virtualization, service analytics in these areas. And Dahou submitted for LSO-inspired data center and cloud connect services in China, assured WAN services based on LSO and SDN, and four-way WAN services based on LSO and SDN. Great honor to be a finalist in this global competition. Please join me in congratulating Dahou Networks. So in conclusion, LSO, with its abstractions, reference points, and APIs, fosters all these advantages for networks of the future. Partitioning complex network architectures into simple ones that you can work on independently, simple parts. Enabling independence of multiple organizations, but collaboration among them so they can do their job without worrying about stepping on the toes of another. Technology innovation in all layers because it is not bundled any longer across layers. Deployment, as we have seen on these slides, of SDN and NFV in real-world use environments. And agile, assured, and orchestrated services that actually make money for the operators starting now. And I believe the acceleration of business opportunities and business success for the entire ecosystem. The digital transformation is hitting every enterprise and every telecom operator, and it's hitting organizations even like MEF. We're living it together. We believe that LSO is a clear way to make progress doing it together. Thank you very much for having me in China this year.